Hello everyone, today's video is going to be a refresher on solving 1 and 2 step equations as it relates to solving a quadratic. So when we're solving quadratic equations, you'll notice that we'll be factoring, for example, right? And you'll have x plus 3, and let's just say you have x minus 3. So this is a factored quadratic equation, of course, and you'll have a factored quadratic, but then we're going to set both binomials equal to 0, right? We would do something like this. And so today's video refresher is not on how to solve the quadratic fully. We have a video for that. Today's video is refresher is how to solve a one-step equation, right? Because here you have, again, a one-step equation once you've set both binomials equal to 0. And so you just may have forgotten, so I'm just going to go over a few examples so you know just how to solve a one-step equation again when it's set equal to 0. Okay, so I'm just going to use a red pencil. For example, we have a one-step equation. You're going to do something called the additive inverse. You may have forgotten about that. You're going to do something called the additive inverse. And why? Why? Because you have a positive 3 next to this x, and really x likes to be alone. See how that 0 is on the side alone? Okay. X likes to be alone and next to an equal sign, right? It doesn't like to have friends next to it. That positive 3 kind of just tagging along. Doesn't like it. So therefore, x is like, get me alone, please. And in order to do that, we have to do inverse operations. There's two inverse operations. One is called the additive inverse for when you are dealing with addition or subtraction, and the other is the multiplicative inverse when you are dealing with something that's being multiplied or divided by x. So right now we just have something that's being added to x, basically. So therefore we're going to use the additive inverse, and basically the additive inverse says that if you have a positive 3, well, in order to cancel out or get rid of or get x by itself, well, you have to use the inverse. Okay, so the inverse of the sign, of the additive sign. So if it's positive, you're going to put a negative under it. If it's negative, then you would put positive. And always remember that you have to be balanced in these equations. So therefore, what you do on one side of the equation, you must also do to the other side of the equation, because it's all about balance, fairness, justice, and reciprocity. So this would cancel out. Positive 3 minus 3 is 0. So it cancels out, right? And then we bring our x down. Okay, and then 0 minus 3 is negative 3. So our additive inverse definitely help us get this x all by itself. Nothing is next to x now. Nothing's being added to it, multiplied by it. X is alone. I'm just going to use the example on the other side as well to do the additive inverse because something is being subtracted. Okay, so you use the additive inverse when something is being added or subtracted from x. So therefore, we use the inverse. The opposite of negative 3 is positive 3. We do it to both sides of the equation. Some of you attempted to put it next to the x, but that's not where it goes. What you do on one side of the equation, you do to the other side of the equation. The other constants, the other coefficients on that other side, you must apply it there as well. Only like terms, remember that, right? So you cross this out, you bring down your x, and then x is equal to positive 3, okay? And then you're done, right? So this is how the additive inverse works. You use inverses to cancel out, to isolate, to move things from one side of the equation to the next. That's how you do that, okay? You use the inverses. So this was an example with the additive inverse, okay? And how it relates to a quadratic equation. I'm just going to do some more one-step equations that are set equal to 0. So therefore, you are getting comfortable with how to use the inverses when something's set to 0. And it'll help you solve your quadratic equations a bit faster, just in case you forgot. All right, so what are we going to do here? We're going to do the additive inverse again. Do I put the negative 4 over here? No, I don't. This would be incorrect, right? This would be incorrect. I do not put the negative 4 over there because that's not both sides of the equal sign. So therefore, let me rewrite that. The negative 4 goes over here, okay? Both sides of the equal sign. This cancels out because positive 4 minus 4 is 0. We get our x is equal to negative 4, okay? So x is all alone. X is all alone. Now, here's another example, okay? This is a two-step equation. So those were all one-step equations, right? And we did the additive inverse. Now, some one-step equations may require you to do either additive or multiplicative inverse. It all depends on what you got. But when something's being added or subtracted to x, then you use the additive. Now, here's the example with the multiplicative inverse is going to be included now. And you're going to see why. You're going to see why. So we have 2x minus 10 is equal to 0, right? So you could end up with a quadratic that looks like this when you are setting both factors equal to 0. I'm just showing you this example here. You want to do the inverse, right? So what's happening right now? We got something being subtracted from our x, and that's a 10, right? So 10 is being subtracted. I'm going to do additive inverse to both sides of the equation. There we go. Okay, I'm going to bring down my 2x, and I'm going to bring down my equal sign, and I'm going to 0 plus 10, we know that that's 10. Now, we're not done here. The first step was the additive inverse. And our next step, right? Our next step is going to be something called the multiplicative inverse. The multiplicative inverse, okay? You have to remember that. So let's do the mul to up. Do I have space? No. Inverse. Multiplicative inverse. You do the multiplicative inverse when something is being multiplied or divided from x. So basically, if you have a coefficient next to x, that just basically means that x is being multiplied with 2. X has been multiplied with 2. And so therefore you have to do the reverse process. So if 2 and x have been multiplied together like that, the reverse process is, you've guessed it right, division. Okay, it's division. So we got to do division. Now it's not 2, we're not dividing 2x because we're just dividing the coefficient next to x to cancel it out. What you do on one side of the equation, as always, the laws of inverses, you have to do to the other side as well. You have to be fair. You divide 2 by 2 is 1, okay? So we're just going to write x. Now, some of you may be tempted to write 1x, but always remember there's a 1 naturally there, so you don't need that. And 10 divided by 2 is 5, okay? So here we have applied our additive inverse and then the multiplicative inverse. And that'll be what sets you free, what sets x free, and you are just, able to get your x equals something, and it's very clean. So again, this is just a refresher to do some examples as it relates to one-step equations when solving for quadratics, and two-step equations when solving for quadratics. We know this was equal to 0 because in a quadratic, you're always going to be dealing with y is equal to 0 because that's where the solution is if you're solving for it. So just as a heads up, and definitely, well, if it has a solution, right, because sometimes it can have no solution. So if it has a solution that does touch that y-axis, then it's going to be equal to 0. Again, get your refreshers going, solving for one and two-step equations, search up some videos on how to do that, and we are done here.